Hello, welcome back to the second portion of our lecture on section 16.4 of your textbook. In this video, we will be discussing mole fraction. Now, we've already used several quantities that start with the letter M lately, and we're kind of out of variables of how to write the letter M. So the symbol for mole fraction is actually a capital X, and the formula for calculating mole fraction is like this. If you were trying to find the mole fraction of substance A, you would write X with the subscript of A, and the mole fraction of A is equal to the moles of A divided by total moles in the mixture. You have to use moles. You cannot use grams or liters or anything else. Another little tip, mole fractions are always unitless values because the moles over moles cancels out, and mole fractions will always be less than 1. So a few other tips. If you had a mixture that contained A and B, the mole fraction of A, so X of A, is equal to moles of A divided by the quantity moles of A plus moles of B, because that would be the total moles since there's only two things in this mixture. The mole fraction of B would be XB equals moles of B divided by, again, moles of A plus moles of B, because that's the total moles. Another little caveat of this, in math class you might have learned that fractions will add up to 1. Like if you had a circle, it's a terrible circle, sorry, but I divided it into fourths, 1/4, 1/4, 1/4, 1/4. Those 4 1/4 would add up to give you 1 because they're parts of a whole. This can apply to a mixture. So if this mixture only contained A and B, we could say that the mole fraction of A plus the mole fraction of B equals 1. If there were 3 substances, the 3 mole fractions would add up to 1 as well. So let's try some sample problems. If you don't have your calculator in a periodic table near you right now, I would encourage you to pause this video and go get them so that you can complete these sample problems. The first sample that we're going to do is actually problem number 18 on the worksheet 15-2 practice problems, which is most likely going to be assigned to you for homework with this. So problem number 18 says, a gas mixture contains 45.6 grams of carbon monoxide and 899 grams of carbon dioxide. What is the mole fraction of carbon monoxide? All right, so let's list what we are given. We know that we have 45.6 grams of carbon monoxide, which is capital C, capital O. Then we also have 899 grams of carbon dioxide, which is CO2. We are supposed to find the mole fraction of carbon dioxide. So we are trying to find X of CO. And that would be equal to the moles of CO divided by the total moles, which in this case, we have the moles of CO plus the moles of CO2, because those are the only two things that we have in this mixture. All right, so the good news is that we've got a game plan here. The bad news is that neither of the numbers that we're given are in the proper units that we need. So let's begin by converting grams of CO to moles of CO. Anytime you go grams to moles, you put a 1 with moles. Then you'll have to do a little scratch work math. You have to find what the mass is of 1 carbon plus 1 oxygen. Carbon is 12.01 and oxygen is 16. So I have the molar mass of carbon monoxide is 28.01. So mathematically, you're going to take 45.6 divided by 28.01, and that should give you approximately 1.63 moles of carbon monoxide. We now need to convert from grams of CO2 to moles of CO2 because both of our values must be in moles. I'm going to put a 1 with the moles. Then this time we're going to take 1 carbon plus 2 oxygens, which has a mass of 44.01. So we will take 899 divided by 44.01, and that should give you about 20.43 moles of CO2. Now that we have both values in moles, we are ready to use our equation for mole fraction. So the moles fraction of carbon monoxide is going to be equal to the moles of CO, which is 1.63 moles. then divide that by the total moles. So 1.63 moles plus 20.43. Now notice that I put this denominator in parentheses because you have to do this addition problem first before you start dividing. And I have that when you do this properly, try that. When you do this properly on your calculator, that this should work out to be approximately 0.0738. And remember, that's a unitless number because moles over moles, your units will cancel out. All right, let's try another problem. Sample number 19 on the 15-2 practice problems worksheet says a gas mixture contains the following gases with the mole fractions indicated. CH4 has a mole fraction of 0.510. C2H6 has a mole fraction of 0.431. C3H8 has a mole fraction of 0.011, and C4H10 has a mole fraction of 0.013. The mixture also contains the gas acetylene, C2H2. What is the mole fraction of acetylene? All right, if we go back to one of our beginning definitions, I said that all the mole fractions should add up to 1. So the mole fraction of CH4 plus the mole fraction of C2H6 plus the mole fraction of C3H8 plus the mole fraction of C4H10 plus the mole fraction of C2H2 should all equal 1 because those are all of the parts of the mixture. Now, if we go back and take a look at what they tell us that the mole fraction of CH4 is 0.510. They tell us the mole fraction of C2H6 is 0.431. They say the mole fraction of C3H8 is 0.011. The mole fraction of C4H10 is 0.013. However, they do not tell us what the mole fraction of C2H2 is. That's what we're trying to find. We do know that these should all add up to be 1 because all the fractions add to 1. So now we have one equation with one unknown and we can solve. We need to begin our solution by adding together like terms. So if I take 0.510 plus sorry, my battery's going dead, 0.431 plus 0.011 plus 0.013, I have that those add up to 0.965. Now, that our equation still says plus the mole fraction of C2H2 equals 1. So to get the mole fraction of C2H2 by itself, I need to subtract 0.965 from each side of the equation. Cancel out here. And so on the left side of the equation, I'll be left with the mole fraction of C2H2. And on the right side, I will take 1 minus 0.965, and that should give me 0.035 as my mole fraction. And remember, mole fractions are unitless numbers, so that is the correct value. All right, so our takeaway summary here is that the symbol for mole fraction is a capital X, that it's the moles of whatever you're trying to find. So like moles of A divided by the total moles. You have to find the total moles, do that whole addition before you do the division. Mole fractions are unitless values, and all of the mole fractions in a mixture should add up to 1.